Alright, so we want to use rate of change and estimate that on this interval, but we want to use the difference quotient, which would be f of x plus h minus f of x all over h. And this is just our rate of change using h, and reminder that h right here represents delta x, or the change in x. So if we're going to do that, we're going to apply it to x squared. So x plus h squared minus f of x all over h. And as we FOIL that out, we get x squared plus 2xh plus h squared minus x squared all over h. Those cancel, which is typical. Your f of x will always cancel out. Secondly, we have an h on the bottom that will cancel out. So we are left with 2x plus h. So what does this represent? This is our difference quotient that says our slope between any 2 points on the graph of f of x will be represented by this equation, where x is your initial x value that you want to use, and h is the change in x. So this is where the interval comes into play. The interval from 1 to 2, and the interval could be whatever you want. So to apply the difference quotient to find the rate of change from a to b, or 1 to 2, we use 1 as our x value. So 2 times 1 plus h. H represents the change in x. So to go from 1 to 2, there's a difference of 1 plus 1. And therefore, the slope, 2 plus 1, 2 times 1 is 2, plus 1 equals 3. So from point 1 to point 2, there is a slope of 3. So if I use the same difference quotient, but say I have the interval 1.1 to 2.3, well, then I would apply the same formula. I would use 1.1 as my starting value, so 2 times 1.1 plus the change in x from 1.1 to 2.1 is a difference of what? 1.2. Now, I don't have a calculator readily available, but you could plug that into your calculator and go from there. But it looks like it would be 2.2 plus 1.2, which would be 3.4. I hope my math is correct, but that's how we would go through. If you have any questions, let me know prior to the quiz on Tuesday.